Bismillahirrahmanirrahim. Welcome everybody. Thank you so much for having me here today. A month ago, I have got a master degree, so what will be presented today is a small part of my thesis. Our research title is Arabic Tweet Act, a graph convolution network-based classifier for classifying Arabic speech act in Twitter. I will go through this outline, introduction and background, literature review, methodology, result and discussion, and finally conclusion. Tweet Act, it's come from Twitter, one of the famous social network, which now as X, that provide a good public channel for people to share feeling, express their idea, ask, request, and so on. Where act come from speech act theory. Speech act are essential part of communication. It is defined in terms of speaker intention and the effect it has on a listener. Austin, in his book How to Do Things with the World, formulates speech act theory and divided it into three components. Lectionary act, saying something that her understand, electionary act, saying something with a purpose, and pre-lectionary act, saying something that causes someone to act. Based on Austin, Searle divided electionary act into 5 points, which are assertive, commissive, directive, declaration, and expressive. Since speech acts appear in written text, we can use NLP technique to automate classification tasks. This is one of research area within natural language understanding domain. Why Arabic? The Arabic language is one of semantic language used as official or co-official in around 20 countries. It is the sixth spoken language worldwide with an estimated 274 speakers in a million. Nizar Habash, in his book Introduction to NLP, divided Arabic language into three forms: classical Arabic, the language of the Holy Quran and the Hadith; modern standard Arabic, the language of media and education in the Arab world; and finally, Arabic dialect, the spoken language used in daily informal communication. Our focus will be on Arabic dialect since it's often seen in the social media. Before we go deeper into literature review, we just need to know the type of conversation. There are synchronous and asynchronous conversation, such as dialogue, meeting, transcript of call center, and so on. And asynchronous conversation, which are such as discussion forum, email, and tweet. There is different work that study speech act of all these type. Also, there are some NLP applications that use speech act, such as rumor detection, topic summarization, and so on. Our focus will be on Twitter, since it helps us to understand user intention, analyze Twitter content, and understanding how users interact on social media. As we can see from this table, tweet act considered as asynchronous conversation. Now for literature review, it's divided into two parts. First, what has been done in terms of tweet act in English language, then speech act in the Arabic language. First, in 2011, Zhang developed support vector machine with different features and evaluate their model using around 8,000 tweets. Their classifier performed an average F1 score of 0.70. Then, in 2016, FOSG developed logistic regression with different features and evaluate their model using around 7,000 tweets. Also, their classifier performed an average F1 score of 0.70. In 2019, Saha developed CNN support vector machine with different features and evaluate their model using around 7,000 tweets. Their classifier performed an average F1 score of 0.71. Next, in 2020, Saha developed BERT without handicraft feature and evaluate their model using the same dataset that FOSG has used. Their classifier performed an average of 0.74. After that, in 2020, Saha developed another BERT model with handicraft feature and evaluate their model using the same dataset. Their classifier performed an average F1 score of 0.77. For the Arabic language, the first work was by Shaqawi. In 2018, they developed a role-based expert system approach and machine learning approach with handicraft feature. They built their dataset with only 1,500 modern standard sentence. They obtained result average accuracy of 98%. For speech act classes, they derived it from classical Arabic sentiment science. الغطيمل in 2019 develop support vector machine with handicraft feature and different deep learning model with only textual feature. They use the RSAS dataset that contain around 21,000 tweets. The support vector machine classifier obtained 86% for accuracy matrix and 87% accuracy for BiLSTM. Then Ahad in 2020 built a support vector machine classifier with extra handicraft feature using the same dataset. They obtained an 89% of F1 score. In 2020, Jukhader evaluated different pre-trained BERT model using RSAS. The best result was achieved using ARABERT version 2 with an accuracy of 89%. In 2024, Al-Shehri contributed to the field of Arabic Speech Act classification. They developed a Dialect Arabic Speech Act dataset that comprises more than 22,000 of unspecified topic annotation with 6 speech acts. They achieved a result accuracy of 0.84 macro average of one score and 0.18 of one score. For the methodology, I will go through this outline, dataset, classification model, performance evaluation. Let's start with dataset. We evaluate our model using two public datasets, which are ASAD and RSAS. The ASAD dataset is public for sentiment analysis task. It is available for research to accelerate Arabic research in NLP. The ASAD was collected using Twitter API between May 2012 and April 2020. First, they select a random set of tweets that has label AR. Then they remove the tweet that contain less than 7 words. Finally, they obtain a corpus of 100,000 tweets. Since the corpus was published with only sentiment analysis, in 2024, the other work had annotated a total 25,000 of ASAD using domain-specific taxonomy for speech act category that are commonly seen in Twitter. Finally, they come up with the corpus of more than 22,000 tweets. For RSAS, is a public dataset. It contains speech act label. RSAS were collected using Twitter API on set of topic, which where a topic is a subject discussed in one tweet or more. The topic is classified into longest time topic, entity, or event. After they collect and clean the data, they annotate a tweet with two labels, one for speech act and the other for sentiment analysis. This chart presents a distribution of speech acts in both dataset ASAD and RSAS, and this table presents a number of samples in each class. For data pre-processing, we do multiple change sample and two tags, such as hashtag, user, URL, all of them changes to tags. We remove all direction, punctuation, and Arabic character, and so on. For RSAS, we merge the two smallest class in one class. And finally, after applying all previous steps, we remove any tweet that had less than 3 words. We follow 18-20 principle to divide our data into training and testing set, where 20% of sample from each class must be present in test set. As we can see from previous chart, the data sets, both of them are unbalanced. So in the previous work, the research used data augmentation technique to overcome this problem. We used the same augmented data set in our experiment. And this chart presents a distribution of speech active classes in ASAD and RSAS after applying data augmentation technique. Let's see about the classification model. We implement two types of graph convolution network, which are text GCN and BERT GCN. For text GCN, we build single large graph that represents entry text corpus. A node in this graph represents both a tweet and unique word. One hot vector to represent word and tweet. A node are connected if word appear in tweet and word edge are weighted based on BMI. GCN allow each node to learn from its neighbor, capture both local and global context. For classification, the document embedded are fed into classifier softmax layer to predict the category of the document. The same thing happened with BERT GCN, except the BERT representation used to represent a word and a tweet as a node. For performance evaluation, we used accuracy, precision, recall, and F1 score. Now, let's go deeper and talk about results. First, I will talk about ASAD results. For GCN, text GCN performed the worst with a macro F1 score of 0.54. In contrast, BERT GCN performed better and achieved macro average F1 score of 0.71. An augmented technique was used to deal with the class imbalance issue. The two GCN model are highly improved. The macro average F1 score of two least frequent class recommendation and other improved that boost the overall F1 score but reduce the other matrix, and it's expected because imbalance datasets tend to classify the more common classes better than less one common. RSAS dataset. For GCN model, the same thing happened with RSAS. 6 GCN performed the worst with macro F1 score 0.35. In contrast, BERT GCN performed better with a macro F1 score of 0.56. In terms of augmented datasets, the same thing happened with GCN model. F1 score highly improved. For text GCN, it's improved to 0.55, and for BERT GCN, it's improved to 0.77. And as a conclusion of our result, in terms of macro F1 score, the best model is BERT with both BERT GCN with both dataset, and data augmented improve Arabic Speech Act classification performance in terms of F1 score. In this work, we investigate, as a conclusion, the Speech Act Arabic in tweet using two graph convolutional network, text GCN and BERT GCN. Based on our finding, it can be shown that BERT GCN model outperformed text GCN on RSAS and ASAD dataset with macro average F1 score value of 0.56 and 0.71. Using augmented dataset, it improved to 0.77 and 0.84. This is some of our reference, and thank you.